So, in the last classes, we talked about using YOLO for object detection. We talked about custom object detection in Collab as well as in your local system. Then, for the same thing, we also talked about TensorFlow object detection and how that can be used, right? So, what we have now completed basically, if we look at our CNN, right? So, the first task was basically your classification task. This is over. The next task that we thought about or that we did was basically object detection. Now the final and the most used CNN task is now segmentation task. So we know the difference between classification and object detection, right? So let us understand more about segmentation. Okay, so here basically this is not going to be a very big topic. I'm just going to talk about this and I'll show you the main architecture that is used for segmentation, which is the mask RCNN. Okay, and then we will officially be done with our CNN architecture. So convolution neural networks will finally be over, and after that what we can do is basically we can start on with our NLP tasks. Right, so NLP basically means natural language processing, and we will be talking about the different languages, how they can be trained, how we can make a chatbot, or how we can make a question answering platform, or how we can do summarization. All those tasks can be done using your NLP, right? So that will be our next task. Next goal will be NLP, but for now we'll be talking about segmentation. All right, so let us talk about and understand first what is segmentation. So here you can see there are very visual understandings of different things. So you have a basic classification here. So in classification what happens? It is just classified, okay, this is just a person or a man or something like that. It will not give any hint or any idea where the person is, right? Object detection, what will happen? See, all these men have been classified and they have been given bounding boxes. So now I know that there are men, but those men are also in which places, that gets given to us. So this is basically classification with localization. So that is what this is called. Okay, the next is known as segmentation. So in segmentation also there are two types of segmentation: semantic segmentation and instance segmentation. So just try and understand what these two are. Okay, so this is a segmentation task. So what happened basically is, see, object detection gives me bounding boxes. This segmentation, it will give me a mask. So this is the mask of the person. So this is one person, this is the second person, in that manner. So here is what we are going to do. Okay, so see, all these people, they all are person. So what it can happen is, one case could be, since we are using a mask to give us out all the outputs, so one case could be that all these people, since they are all from the same class, what will it do? It will give us the same color, that all these people are here. Or what it can do is, it can identify each and every person individually, each and everything, and it will get, okay, this is one person, this is the second person, this is the third person, fourth person, and fifth person, right? So instance segmentation basically means it gives out the each instance in the class itself. Okay, so this is a person class, the whole thing is a person class, but even then it is giving out some instances of each the class. Okay, and semantic segmentation basically groups all of them together as one. So this is the basic difference. We are going to be talking about mask RCNN. So mask RCNN basically is instance segmentation. Alright, so we are not talking about semantic segmentation because this is not used a lot. If you think about it, it is more easier for us to get each and every object in differently rather than all of them together. And once we have all of them individually, we can maybe then combine them all together to form this part, right? So what I'm going to say is that this is more important. So we will be talking about instance segmentation. All right, and most importantly the architecture, where there are a lot of architectures. You might hear of YOLO Act. So this is also for segmentation and everything, but we will be only talking about mask RCNN because this is used more, and this was released by Facebook. So Facebook, yeah. So let us talk about the structure of mask RCNN. Okay, so this is your basic mask RCNN structure. So it's not that different. Okay, if you remember, it is very similar to a faster RCNN structure. So what is happening is, see this part, this whole thing, this blue part, this belongs to the faster RCNN structure. So faster RCNN, what was happening in there? So there what was happening was, it was giving us the bounding boxes for each object. Along with this, if we add one other network to it, this becomes an instance segmentation or mask RCNN. So it is not that different. So let us first go and revise back to what we learnt about for faster RCNN, right? Once we know this, it will become easier for us to do everything. So what happened in faster RCNN was basically what they used was an RPN. RPN was a region proposal network, right? So they made a network, and in that network what was happening was, if you go here you will see, so there was a network. So once you had the network, what was happening was you did ROI pooling, right? And you got all the sizes, all feature maps and everything. Once you had that, they were classified into two classes. So the first class was basically, it gave out whether it is background or not background, right? So one was that, if you remember, and the other was basically, it gave out the outputs of the bounding box. So this was the whole structure about faster RCNN. It was nothing, it was very similar to fast RCNN. The only difference was, instead of using selective search, we were now using an RPN, a region proposal network, right? So what was happening, once again if we go through this, so there was a region proposal network, it gave out the regions. Once you had the regions, they were aligned, or they were pooled into the feature maps. In the feature maps, they were aligned and you got the feature map sizes. Once you had that, the next thing what was happening was, basically the sizes were changed and everything. You had the ROI pooling, and then finally you had two different types of sibling models or sibling architectures that were able to, sibling branches that were able to say whether it was a background or not a background. And if you did not have a background, it gave us the bounding box sizes, right? And apart from that, one other thing that it did was, basically it had a 3x3 sliding window. So while sliding, what it was doing was, it was giving out 9 anchor boxes for each 3x3, right? And so you were getting, according to that, the number of objects, right? And you were getting the whole thing. So this was the whole thing about faster RCNN. So now what we will be doing is, we will just be using the faster RCNN part, and we will be adding instance segmentation to it. That is it. Okay, and there will be one more thing. Instead of ROI pooling, we will be doing ROI align. Okay, we will talk about that. So this is the main structure. So you have the mask RCNN architecture, which is basically faster RCNN plus masking layer or model, whatever. Then you have the feature pyramid network. Feature pyramid network, what this does is, basically, if you talk about pyramid, like if you see, how does a pyramid look like? It goes on like this, right? So feature pyramid network, what basically does is, if you have the image of this size, so it will reduce the image sizes, so you can get the feature maps of different sizes. Alright, so irrespective of the size, you'll be able to get the feature map. If you remember, that is what we saw when we were doing YOLO. You had a cat image and you had a dog image. So if you remember, you were able to capture one using very small feature maps, and the other using big feature maps, right? So that was the whole point of this. So yeah, so what we will be doing is, basically, then we will be using a feature pyramid network. So it will basically be used so that we can get features of all sizes, and then it will have a region proposal network. This is the same thing as faster RCNN. So this region proposal does not change, it is the same thing. Here, instead of ROI pooling, we will be having ROI align. We will talk about this, okay? And once that is done, you have this mark RCNN head network. So this part is basically that mask part. This instance segmentation part is the one that they are talking about here, okay? And this is the whole thing about mask RCNN, okay? So now what we'll be doing is, basically, understanding this more in details, okay? So first you have an image. So image is passed through a backbone network. So in this case, our backbone network is what? ResNet, right? Once you have ResNet, the next thing that you will be going to do is pass this through a feature pyramid network. Feature pyramid network, what it will do, it will change the image to different sizes. Once you have that, what you can do, it will be passed through region proposal network. So you'll get regions from all these different features, different images. So now you'll be able to, so the image is same obviously, but from different sizes, scales. So now what you'll be able to do is you'll be able to get or capture better feature maps. So once that is done, you will now add this here. Okay, so now using the whole scaling thing, scaling factor and everything, you'll be able to scale it down for our image, right? So now you have all the region proposals. The next thing that we will be doing is what is known as ROI align. Okay, so you remember ROI pooling, right? So if we go back, see, this was something like that, and we remember if we had to take something, so what we used to do, if we had a 2x2 architecture, right? So we would take this 2x2, which was followed by another 2x2, then another 2x2, and whatever was remaining, right? If we had 3x3, in that case we would take this 3x3, then we would take this, and then we would be left with only 2, right? If you remember, this was what we were doing, right? So the one problem that was there was, see, earlier you were able to get the sizes that was required, but later on what happens is whatever is remaining you have to keep it together. So you might be getting 3x3, 3x3, and then the next time you are getting 2x3 or something like that. So this causes irregularities, right? So the whole thing is not being divided equally, so this causes problems. So what we will be doing is, instead of doing ROI pooling, we will be doing ROI align. So ROI align, what this basically means is, see, irrespective of the size, okay, it will be divided into equal halves. So if you say here 1 2 3 4 5 6 7, so this is my feature map size, this is a 5x7, alright. So if you will divide this 5x7, it will come to 2.5 and 3.5, right? So here that is happening. See, the same thing is happening here, one box, second pixel, then another half pixel. In the same manner, if you see this in this direction, here you have 3 pixels and another half pixel, right? So what this means is basically, see, you have it and you are dividing it into blocks, and these blocks are now of equal sizes. So how do you solve this? Well, you solve this using something that is known as bilateral interpolation. Now this is a very big thing in itself. If you want, I would suggest go to Wikipedia and read about this. They describe everything very beautifully, so you can understand about it. But yeah, so we are not going to talk about that because it's a big method. So the whole point of this is basically it gets divided into different sizes, different blocks, and the whole thing is all the blocks are of different equal sizes. Okay, so the sizes are equal irrespective of whether you are using half a pixel or more than half a pixel or whatever, right? So this was basically our whole task. So this is a difference that has been made. Instead of using ROI pooling, we'll be using ROI align, so that we get more regular sized boxes rather than some same size and some other sizes, right? This was one of the problems that was having in faster RCNN. Okay, so ROI align happened. The final thing that we will be talking about is this mask RCNN architecture. Okay, so this is nothing. They have two convolutions, one after the other, and then each convolution, I think it is a 28x28 map at the end, and then each of this is required to give out a value, a mask value, and using all those values, all of it is joined and you get the object. Okay, so this is not that bigger deal. So this is basically a segmentation thing. Here you have one convolution, here you have the other. The final you have 28x28 feature map size, and once you have that, what will happen is, see, you have 28x28, right? So each of this will be responsible for giving out one value, and once you have all those values, you will join the whole thing and then you will get your object. So this is the whole thing about mask RCNN. Okay, and this is basically used for your instant segmentation task. I am not going to go and make you talk to you about how this is done practically. Okay, so if you want to, you can go and read on your own. There is this GitHub called Matterport. They released mask RCNN. Okay, so you can go and you can read about this and you can do it in your own way, but I am not going to go over with this. So this has been done. The whole structure of mask RCNN is basically you have a backbone architecture, right, and that is followed by a feature pyramid. So this is new, a feature pyramid network is new. Once you have that, it is passed to region proposal networks. So what happens then is basically, because the sizes are different, your region proposal network is able to identify small as well as large features. Once you have those features, now using scaling factor and everything, you place those features or those bounding boxes into your image, and then it is followed by an ROI align. So ROI align, basically what this helps in doing, this helps in basically not giving us irregular size boxes. Once you have that also, the next thing that you will be doing is basically here you have some convolutions and everything, and then this will be followed by what is known as this basic faster RCNN structure. So you have convolutions which will be able to give the classes. The only classes that we are able to detect or we have to detect is whether it is a background or not a background, and then it will give you the bounding box classes, right? And then at the same time it will also have a sibling architecture or a sibling layer, and this will be basically used for your mask purposes. So this will be your segmentation task. Alright, in here what will happen, the final one is a 28 cross 28 feature map. Each feature map is responsible to give out one value, and all these values joined together will form your final mask RCNN architecture. So here let us look into the architecture. Okay, so this was the RCNN architecture. Here your region proposals were done using selective search, alright, and then it gave out box values, regression values, and then an SPM. Okay, then you had fast RCNN. Fast RCNN, what it did was, it did the same thing. Here instead of SPM you had softmax classifiers. Then it was followed by faster RCNN, where you used RPNs instead of selective searches or region proposal techniques. Okay, so now this RPN was basically what feature, so this was basically able to detect all your features. Then once you had that, again the whole thing was more or less the same. Here what was happening was, along with giving the box values as well as whether it is background or not a background or foreground, it also gives out your mask values. Okay, now this is the whole thing about mask RCNN. Now let us talk about the loss. So the loss is not very different. You have the loss of the class plus the loss of your regression, that is bounding box values, and finally you have the loss of your mask. So these two losses are same as faster RCNN. If you do not remember, I would suggest to go back and look into the video where I teach about faster RCNN and understand about these two losses. And about the final loss, that is the loss mask, this is basically a log loss. Okay, so this basically is the log loss value that we'll be using here. Okay, so you will get the actual value yi and then log yi hat, and then this will go on for all the classes. Okay, so you will have summation and everything, and this will go on. So this is basically the loss of mask RCNN. I hope you understand the structure. Again, I'm saying, if you want to try this out in real life, I would suggest to go into the website mask RCNN or into the GitHub and understand how this is done and go through it. So from the next class on, what we will be doing is we'll be talking about NLP, natural language processing. Okay, so we'll talk about tokens, we'll talk about how this is used, how we can use in different cases, and then we will also go through some studies, some projects, so that we can do on our own. And yeah, I hope that is it. So that is it for today. I hope you enjoyed and keep learning.